In this video, we'll take a look at how to represent a chemical plant in a drawing. To describe a plant and its processes, we usually use three types of flow diagrams. These are the basic flow diagram, the process flow diagram, and the PNID, which stands for piping and instrumentation diagram. All three types are standardized according to technical norms. Let's start with the basic flow diagram. Here's an example of what such a diagram can look like. On the left side, we see the feed materials, additives, solvents, and their flow rates. In the middle boxes, we have the process steps, for example, dissolving, reaction, and separation. Important operating conditions are also shown here, such as 1 bar and 40 degrees Celsius. So, in this example, the dissolving process takes place at 1 bar and 40 degrees Celsius. On the right, we see the final products, solvents, and, for example, off-gases. Pipelines are represented by lines and arrows. Thicker lines show main product lines, and thinner ones indicate byproduct lines. The exact thickness is defined in the standards. Now, what can we read from this basic flow diagram? We can see that the solvent is fed at 1,000 kilograms per hour, and the main raw material at 800 kilograms per hour. It seems that the raw material is dissolved in the solvent at 1 bar and 40 degrees Celsius. Then an additive is added, and before that, it is crushed, which tells us it's a solid material. The dissolved raw material reacts with the additive at 1 bar and 80 degrees Celsius. After the reaction, we move on to separation. Here, 700 kilograms per hour of solvent are separated, and 1,450 kilograms per hour of product are obtained. All this information can be read directly from the basic flow diagram. So, everything essential to understand the basic diagram is shown here. Now let's look at the process flow diagram. This type already includes more details and more symbols. We can see the symbol for a stirred tank, a crusher, several pumps, and a heat exchanger. These symbols can be found in a chemical engineering textbook or in the Chemical Engineering Data Handbook. Both are great resources to learn and recognize all the standard symbols. So, what can we learn from the process flow diagram? We can see all substances and flow rates, all equipment and machines with their symbols and abbreviations, the operating conditions, and the energy sources. Basically, it shows us everything we need to understand the process more clearly. That's exactly what the process flow diagram is for. Here we can see both diagrams together, the basic flow diagram and the process flow diagram. In the process flow diagram, we can see that the raw material and the solvent are dosed into vessel B. This vessel has a stirrer, so the two substances are mixed, and dissolving takes place at 1 bar and 40 degrees Celsius. Then, the pump PL1 transfers the solution into vessel B2. Here, the crushed additive is added, and the reaction takes place at 1 bar and 80 degrees Celsius. After that, pump PL2 sends the mixture through a heat exchanger into column K1. Our final product, at 1,450 kilograms per hour, is collected from the bottom of the column, while 700 kilograms per hour of solvent vapor leave at the top. So, now we also understand everything important about the process flow diagram. Finally, let's take a look at the PNID, the piping and instrumentation diagram. Here we can see all important energy sources, feed materials, additives, solvents, products, and their flow rates. The PNID also shows the materials of construction for all pipes and equipment. We can see whether the equipment is insulated or heat traced, and all control loops and process control systems are shown as well. At the bottom of the drawing, there's a table with all important equipment data, and the designation showing which part of the plant the PNID belongs to. And here, you can see all three flow diagrams at a glance. The basic flow diagram helps to get a quick overview of the process. The process flow diagram shows more details, including the key equipment and machinery. And the PNID shows everything, from equipment data to the control concept of the plant. If you'd like to learn more about flow diagrams and their symbols, I recommend checking your chemical engineering textbook. There you'll find all the standard symbols for equipment and machines used in process engineering.